Types of functions. In mathematics, a function is a relation between sets that associates to every element of a first set exactly one element of the second set. Typical examples are functions from integers to integers or from the real numbers to real numbers. For a function f from a to b, following possibilities are there. Distinct elements of A have distinct images in B. More than one element of A may have the same image in B. Each element of B is the image of some element of A. There may be some elements in B which are not the images of any element of A. Basing on the above possibilities, let us define a few types of functions. 1-1 and many-1 functions. If each element in the domain of a function has a distinct image in the codomain, the function is said to be 1-1 or injective function. If there are at least two elements in the domain whose images are the same, the function is said to be many-1. Example: f maps R to R given by f of x equals to 3x plus 5 is 1-1. F maps R to R given by g of x equals to x squared plus 1 is many-1. Observe that lines drawn parallel to the x-axis from each corresponding image point shall intersect the graph of y equals to f of x at one and only one point if f of x is 1-1. There will be at least one line parallel to x-axis that will cut the graph at least at two different points if f of x is many-1. Note that a function will either be 1-1 or many-1. If the function is entirely increasing or decreasing in the domain, then f is 1-1, else many-1. Any continuous function f of x which has at least one local maxima or local minima is many-1. All even functions are many-1. All polynomials of even degree defined in R have at least one local maxima or minima and hence are many-1 in the domain R. Polynomials of odd degree can be 1-1 or many-1. A function f maps A to B is said to be a 1-1 function or an injection if different elements of A have different images in B. Thus, f maps A to B is 1-1. A is not equals to B implies f of A not equals to f of B. If and only if f of A equals to f of B implies A equals to B for all AB belongs to A. Example: let f maps A to B and g maps x to y be two functions. Clearly, f maps A to B is a 1-1 function. But g maps x to y is not 1-1 function because two distinct elements x1 and x3 have the same image under function g. A function f maps from A to B is said to be a many-1 function if two or more elements of set A have the same image in B. Thus, f maps from A to B is a many-1 function if there exists xy belongs to A such that x not equals to y but f of x equals to f of y. In other words, f maps from A to B is a many-1 function if it is not a 1-1 function.